Hello students, we have already taken two topics which is trigonometric ratios introduction and trigonometric ratios for the specific angle. This is your third topic which is trigonometric identities. Now what are those three identities? As you are aware, the first identity here, these are called trigonometric identities, and the first identity is sine square theta plus cos square theta is 1. Then the second identity, we take it as 1 plus tan square theta is equals to sec square theta. And the third identity, we have it 1 plus cot square theta is equals to cosec square theta. Right now, the first identity, sometime the proving these, you can prove all the three identities. It's a universal truth, and you are going to use these identities to do the proving questions, right? So how, let us see how do we prove it. The first identity, which is, how do we prove that here identity 1? If I have to prove, sometime this question comes in your board exam also, what to prove here? Y sine square theta plus cos square theta is always 1, right? So how will we start here? We will start always given with a right triangle. So let us first draw a right triangle. So here, if I take any one right triangle and take any one angle theta there, one of the angle you mark it acute angle as theta. So here if I'm taking triangle ABC, where this is angle B is 90 degree, and if I take angle C as theta, so what can I write down in the given part here? We can take here in triangle ABC, angle B is 90 degree and angle C if we have taken as theta. This is given. What is to prove here? If I take here, to prove is going to be sine square theta plus cos square theta is equals to 1. Now, and after that we are going to take the proof. Now here if you will see, you know that anything that we are proving, we can take LHS and we can reach to RHS to show that y sine square theta plus cos square theta is 1. So let us start with sine theta, because here the trigonometric ratio is sine theta, and you remember this SOHCAHTOA to know the trigonometric ratio. If you will see, sine is opposite by hypotenuse. So with respect to theta, if you will see, this is the angle theta, this is opposite side, this is your hypotenuse. So how are you going to take it here? Sine theta is opposite, which is side AB by AC, right? Now I need here sine square theta. So we will do here squaring both sides. If you will do it, you will get sine square theta will be equals to AB square by AC square. This is your first equation. Similarly, if I have to take here cos theta, then what can we take it here? Cos theta is SOHCAH. So it is adjacent by hypotenuse, adjacent to angle theta is BC by AC. Right? Again, we'll do squaring both sides. So it's going to give you cos square theta is equals to BC square by AC square. This is your equation 2. Now how are you going to take it? We need the sum of these two, right? So I'm going to add these two equations. So whenever you add two equations, its left hand sides will be added and the right hand side values will be added. So let us do here, the left hand side value is sine square theta plus cos square theta, which is equals to AB square by AC square plus BC square by AC square. Because we have the common denominator, you can take AB square plus BC square by AC square, right? Now here if I'll see using Pythagoras theorem, you know that here AC square is equals to AB square plus BC square. What is the reason here? It's Pythagoras theorem. Because it's a right triangle, we can use here Pythagoras theorem, right? Now we have the value of AB square plus BC square, right? So let us substitute here. What are you going to get it here? Sine square theta plus cos square theta, which is nothing but AC square by AC square, which is going to be 1. So therefore we reach to the identity result. Sine square theta plus cos square theta is 1, hence proved. Sometime as a 2-marker question you get this identity to prove here in the question. So this is done. The first identity is completed. Now you must know that whenever we solve the questions, identity based question, here you see that because the very important algebraic identity we use here a square minus b square, which is a plus b times a minus b. So what is going to be the variation here? I can write down here sine square theta in terms of cos square theta, or I can write down here cos square theta is 1 minus sine square theta. So you can write down a square minus b square from both the identity. Now let us go for the second identity. Later on we'll see how do we use these identities to prove the question. What is your second identity? 1 plus tan square theta is sec square theta. Generally, you don't get the proving of these two identities, but let us see here 1 plus tan square theta is equals to sec square theta. Now, in the same way, if I take this triangle, I will take the values of, I can take the values of here ABC, again angle C is here your angle theta, right? So let us find out the values of tan theta and sec theta for the same, right? So here if I'm taking here, you can write down given to prove. I'm just taking the proving part here. Tan theta is this angle, again opposite by adjacent. Opposite side is AB by BC, right? So let us take here tan theta is nothing but tan square is equals to here tan square theta. If I do squaring both sides, it is AB square by BC square, right? This is your first equation. Similarly, if I have to get the sec theta, what are you going to get it as sec theta? Sec theta is the reciprocal of cos. So we are having hypotenuse by adjacent. What is hypotenuse? AC, and adjacent to angle C is, or theta is your BC. So you write down here BC. Again you will do squaring both sides. So it is sec square theta is equals to AC square by BC square. This is your equation 2. Now how do we reach to this result? If you will see, if I take the LHS, we can take the left hand side, which is 1 plus tan square theta, because this is another way. We can take one of the side, we can reach to RHS to show that both the values are equal. So let us substitute here. Tan square theta is AB square by BC square, which is nothing but here, if you will get it, if I find out the LCM, then it is BC square plus AB square by BC square. So BC square is your common denominator. Now again using Pythagoras theorem, AB square plus BC square is nothing but AC square. This is using Pythagoras theorem, right? So substitute that value here, Pythagoras theorem, then I can have it here BC square plus AC square. In place of that, I can write down AC square by BC square, which is nothing but AC by BC whole square. And you know that AC by BC, it is nothing but hypotenuse by adjacent, which is going to be sec theta whole square. So we reach here, we started with left hand side and we reached to right hand side, which is sec square theta, which is RHS. So we proved that LHS is equals to RHS. Hence our identity is true. 1 plus tan square theta is equals to sec square theta. Same way you can prove that here. What is the third identity? 1 plus cot square theta is equals to cosec square theta. But here also you should know a square minus b square identity is very important in these trigonometric proof, because here we have to divide the values, so we need the factorized form. So here how are we going to write down? Sec square theta minus tan square theta is equals to 1. So yeah, you can remember both the rules here. This rule, which is 1 plus tan square theta equals to sec square theta, or you can remember as sec square theta minus tan square theta is 1. Similarly, you will have the third identity, which is 1 plus cot square theta is equals to cosec square theta. Right? And if I take it here, it's a cosec square theta minus cot square theta is equals to 1. So these two, I'm not taking the proving part here. Hope you have understood this. Now, how do we use these three identities to prove the identity based question, right? So let us take here, sometime you have to represent the one of the ratio in terms of some other ratio. So let us see some practice questions. You will understand how do we use these identities. So your first question is, express the ratios cos A, tan A and sec A in terms of sin A, right? Now here what do we do here? So you need to write down cos A in terms of sin A. So first thing, cos A in terms of sin A. How are we going to do it? So we know that cos and sin relating these two trigonometric ratio, we have one identity, which is sin square A plus cos square A is equals to 1. Now I need the value of cos A. So let cos square A to the LHS and transpose sin square A to right hand side. Now if I need cos A value, so cos A can be equals to under root 1 minus sin square A. So how are you going to write down cos A in terms of sin A? This is the way we write down. Okay. Then this is your first value. What is your second value here? If I need to write down tan A in terms of sin A. Now tan A, you will start with tan A. How do you relate tan and sin? So you should know that we have learned tan A is nothing but sin by cos. So sin theta, which is sin A by cos theta. Sin A is already there. So we are not going to do anything because we need tan A in terms of sin A. So numerator remains as it is. Denominator from 1 you can take cos A is equals to under root 1 minus sin square A. So I can write down here 1 minus sin square A. So this is tan A in terms of sin A. Right? Now the third one, how are you going to write down sec A in terms of sin A, right? So sec, you know that first you will start with sec A, which is the reciprocal of cos. So 1 by cos A, and we are already having the values of the value of cos A. So you have to just transpose sec A is 1 by under root 1 minus sin square A. Now you can write down all these three trigonometric ratio in terms of sign, right? So hope you understood this. So this is one type of question.
Thank you for watching this video. Please like, share and subscribe. Also keep practicing.